So, welcome back to Map 23, and today will be very busy. We'll be covering three chapters. Actually, like, the rest of chapter 3, chapter 4, and part of chapter 5. So, it's gonna be a pretty busy day for all of us. So, but anyhow, it's not gonna be something that you see a lot. And I'm gonna post the exam review after this week. So when we come back next Saturday, we're going to be working on the rest of chapter 5 and um, and the exam review. So after that, we're gonna have the third exams on the following Saturday. So let me just double check that. Let me just repeat that again. We're trying to have the exam review. I'm sorry, the exam in the following Saturday. So that would be on October 10th. So on that day, we're gonna take the exams. So that's really
Mommy.
all right. So I uploaded the material on chapter 3 and 4, and it's always really important. The material it's what we have would be the summary for 2 chapters. So that would be the practice problems. So those are something that you're gonna see on the exam. So I just want to remind you that the thing that we have learned so far on chapter 3. So I know that we have been away for a week because of the holiday, so we couldn't see each other last Saturday. So let me just remind us what we have for chapter 3 that we learned so far. So chapter 3 that we have learned the mean, the standard deviations. So we can't run away from it. You're gonna see this question over and over again on the third exam and the final exam. So the mean and standard deviation are super important. Um, so we need to know how to evaluate the average, and then we need to know how the data set's going to scatter away from the mean, whether or not it's generate a big gap or basically the small gap consistently. So the mean and standard deviation have to be on the third exam and the final exam, so we can't run away from it. The second topic that we have learned will be the final number summary. So again, that this is also a very important topic where we need to figure out a Q1, Q2, and Q3. Okay, so the smallest and the greatest number, I forgive you, you forgot it. So it's literally 5 numbers, the smallest and the greatest, right? And then Q1 and Q2 and Q3. So the Q2 have to be done first, and then the Q1 and Q3 will be the median, respectively, that occupy 25% quartile. So for the mean standard deviation of quarter, we need to make a chart. At the same point, if you don't make a chart, then it's really hard to get it done. So this is how we're going to show work on the exams, right? So we're going to make the chart, make a table. Okay, so for that one, you need to look for uh, we need to look for the average, right? Q1, Q2, and Q3. So I believe it's important. Okay. So for that one, we're gonna look for um, Q2 first, and then Q1, Q1 and Q3. So if I give you this question on the exam, it can be the combination, but usually, if I give you this question on the exam, we should be able to finish it in around 10 minutes for that. So look for Q2, which is the median, and then we look for Q1 and Q3 respectively. Um, Need to make sure when we're going to cost out Q2 if there's only one median, right? If there are two middle data set, then we're going to take the average of two of them, and one will be going for Q1 and the other one's going for Q3. So that's really important. And so for those of you who actually missed the quiz number 1, just email me, and then I will let you make up the first quiz. I know there was some technical issue like on the first day because of the fact that we sometimes forgot how to submit work on Blackboard for quiz number 1, but this is the only quiz that I make that exception. So making sure that for the next quiz that you have to be on time, you have to take the quiz and upload it on Blackboard. So concerning the quiz question, some of you are very worried about the quiz number 1. So the reason behind that, because I actually got rid of the quiz 1, so I just have the submit work. So literally, this is the thing that we're going to keep on the quiz number 1. So this is what I have for the grade. You will not see any other grades besides the quiz 1. So I guarantee you that the first one just something that I want you to look for the questions, and then we do the work along the way. Okay, starting from quiz number 2, I will basically do the same thing. Make sure that we need to submit work to get a full credit for that. If you don't submit work, you only give me the answer for that. You don't get point. Making sure that we submit work on Blackboard. That's important. Um, so today that we're going to be learning the last topic, which is called step by step theory.
Professor, I'm sorry. Good morning.
Good morning. Yeah.
I have a questions about the quiz. That day when I opened my quiz, you say you could open and see, and then you do it later. It went straight and put me a 0. Then when I really did later, so it put my grade. So it's showing one with 0 and one with my grade. So double check please for me.
No, you don't see the 0 grade anymore.
Okay.
Yeah, so you can double check on my grade. I remember that I only grade the work. I don't grade the answers. So the answer will be graded systematically. Um, so so they don't know how to give the partial credit for that unless I specify what is the partial credit for that question.
Okay.
But generally, you should not worry about that. The system just graded systematically. Like maybe you got 0 on it, but because you got the little slightly different answers, like a few decimal places off. But when I regrade them, so this is the grade that you should have. It's similar to the final exam where we're gonna take the exam not on this web page, on the web work generally. But some people actually got like 20 points, but still get 95 for some reason, because of the fact that, well, they put out the answers, but not the way that the system goes. So when I look through it and then you submit work on Blackboard, I see what it is, and then and that person actually did really well on it. So you still get a grade that you deserve.
Thank you.
Yeah. So again, that the work is super important. If you show me the work, even if you got the wrong answers, I still count most of the credit for that. But if you don't show me the work, even if you get the right answers, I don't get point for that. Even if you got everything perfect, like perfect answers for each questions, but you don't show me the work, how you got the answers, I still give you 0 on that question. Maybe like not 0, but still you only have like very little partial credit for that. So let me just make myself clear. The answers is only part of it. The most important thing is the step how you're going to solve or approach the problem. So, yeah, any other concerns? Yes, good morning. So we're going to have a little talk at the end of class. Yeah, so now we're going to have the last topic. The topic will be called a step-by-step theorem. So I'm not sure how I'm going to write his name correctly, to be completely honest. So TChevbychev. Okay, so TChevbychev theorem. How is that possible? Okay, it's just not cool. TChevbychev theorem. So this is a theorem that we're going to be working on for today. So it was, if you ask me who that person is, I only know that he's from Russia. Back in the day where statistic wasn't really popular at that time, and he was the one who actually did a lot of work on it. He's more like a VIP person in statistics. He's super smart. He also very good at playing chess too. He's beating a lot of opponent, and but I couldn't really write his name correctly because I don't know Russian. And I asked one girl like a few semesters ago and how she write him down, and she told me that we have a letter T in front of it. Okay, so I follow her way of writing down the Shep theorem. So generally, this is the name of a very famous mathematician back in the day. So I have no idea what that person is. Yeah, it's part of chapter 3. It's really, really important that you're going to see this question on the exam. So what is the step-by-step theorem looks like? So this will be something that we cover for today, right? And so we're going to have a review of what a step-by-step theorem. So the step-by-step theorem is something that he utilized. The mean and the standard deviation. This is what the curve looks like, okay? But we only work for 2 numbers. The reason why we only work for 2 numbers because we can't really. Am I breaking up right now? Hello.
No.
All right. Good morning. So the reason why we only work for 2 numbers because I don't want you guys to follow the formula right there. So a lot of us like people last semester asked me how did I get 75% and how did I got 88.9%. Well, it's basically coming from the formula, but we're not trying to prove it. I can show you one you want, but generally we just memorize it and no, I mean we don't even memorize it. We just need to know what it is and do it on the exam. So this is what the model looks like, and he was super, at that time he was super smart to be complying. I have so much respect for his guy. Regardless, I couldn't really, regardless of the fact that I couldn't really write his name correctly. So what we have will be this model. So this is what he claimed. So what he claims is that, well, it worked for any model, right? So it worked for any model. So it doesn't really matter if like it has like mountains or the shape is any shape. It works for all shapes generally, right? So it's work for all models. Just want to make sure that it's a really really powerful theorem. And so what he meant was, if you give me a certain mean and standard deviation, for instance, so this is one of the application, right? So this is what we call the average, right? So we call the average right there. So if you give me the average and if you give me the standard deviation, then I will be able to get everything. And then if you give me the STD as well, we call STD.
Standard
Yeah,
deviation?
yeah, the standard deviation we call STD. So that's important. Okay, so this is what we call STD, the standard deviations. So the reason why I write them the STD just because I'm a little lazy for that. I didn't want to put like the whole word, so STD would be an appropriate term for this. So what he meant is I'm going to capture the number of data set at a certain range interval base point the average. So the average is basically the central, because we know the fact that the average that we have right there was the central tendency of of the model, right? So this is always be like the middle point, and yeah, it's also sufficient statistics. So the average is really really important. The average and standard deviation. So these 2 parameters are way important. It's just determine all of the model and all of and most of the statistics data set. Yeah, average is basically the mean. Okay, so the mean is the central tendencies, but average is more like high school based level because we don't really get used to the term mean, but mean is more generalized in statistics that people utilize it to say that this is a central data set point. Okay. Yeah. So what it means by the central data set point is just average out. It's just centralized. It's just basically when you compute this, when we compute the average, and then we look for the deviation. That when you add up the sum, it's going to be 0 because the central data point just neutralize all the data set from the left and the right. Correct. So that's really important that we have to be able to take this as the middle data point. So so this one is going to be the middle one. So, and then I put down the curve. I'm going to use a different marker for that. Just want to make sure that we have what it is. So this is more like central. And then what's going on for that is, so we're going to take the standard deviation at the step. So what does it mean by the step? So the step, it's more like we're going to determine how spread of the data set is, right? So the step is really, really important. So when the standard deviation becomes the step, it's going to give us the interval on either the left and the right. So we're going to take that step, and then let's say we're going to step one step forward to the left. Okay, so we generate a certain range for sure, right? And then once another step forward to the left as well. So within two standard deviation from the left and two standard deviation from the right. So remember, we take the standard deviation as a step to measure how much the data set scatter around the average, right? So we can also utilize the standard deviations to form an interval, and then we can determine how many percentage of the data set will fall within that interval. So this is what he came up with the theorem. So in other words, that we utilize um, the mean and the standard deviations to determine the number of data set. Right? So it can be like in terms of percentage, okay? In terms of percentage, like 30%. You know, for instance, I can tell you that there will be 60% of people who have the score between 60 to 80, for instance. I'm sorry, 60 to a 90, for instance. So this is what I can determine. Okay, so we utilize the mean and standard deviation to determine the number of data set within that interval. Okay, within that interval. I want to change different marker, just one within that interval. Okay, so this is really, really important. So we're gonna take the average and the standard deviation to set up that concept. So for instance, I can literally check that, for instance, there were 60 or 70% of the student who got the exam score, who got uh, between 65 to 95, for instance. Okay, so the rest of them will be falling away from this range. So in other words, we can have 70% that belong to 60 to 95. So this is just another way that we can say there will be 75%, 70% of students have the score between this range, meaning that there will be some people who get more than 95. They will have 30% who got less than 60, and you know, and greater than 95. But this is not the whole point. The whole point is we need to make sure that this will be the way that we determine the interval. So what he did was he actually had the formula for that. So the K represent the step of the standard deviations, but I'm not going to go over this. So let's say K equal to 2, for instance. So what he did was something like right there. So I'm going to show you one, and then we go over it. So K mean represent the step. So if we step 2 step ahead to the left and 2 step to the right, so we're going to generate the standard deviation, which is x minus 2 standard deviation, x bar plus 2 standard deviation. So what he did was 1 over, so K equal to 2, because we step 2 steps. So we're going to take 1 over 2 square, and we're going to have, which is 1 minus 1 4, and the answer for that is 3/4. So so we're going to take this fraction, and then we subtract from 1, and then we look for the common denominator. So this is 3/4. In other words, it is 75%. Yeah, this is how he came up with the formula. But we're not really interested in knowing that, right? Remember, we're not interested in knowing all of that because is it? Are we good? Is it breaking up? So let me know if this is breaking up for that. If you can't hear me, let me know. Sometimes my connections is not good, but today I feel like it's pretty good for that.
You're
Okay.
fine.
Is it?
Okay.
Let me just raise my volume a little bit. Probably that because we have some background noises, but I would try to make sure that there's no noise. Okay. All right. So I feel like it's getting better. Is it? Okay. So what he said was, if we step 2 steps to the left and 2 steps to the right, and then we're gonna form the interval. Like we're gonna take the x bar minus 2 standard deviation, x bar plus 2 standard deviation, and he guarantees us this will be specifically greater than around at least 75% of the data set we fall within that interval. So that's really, really important. Okay, so this is what he claimed. Okay, but we're not trying to show all of this calculation in class because of the fact that it's not important, it's not necessary. We just want you to know there will be 2 numbers that we need to take care of. Okay, so what he claimed is within 75%. So we're gonna take that 75%. I'm gonna make it a little bigger because that's really important. Within 75%. So we're going to take what? There will be at least, so he claimed was at least 75% of the data set will have this range. If we know the mean and standard deviation, remember, if we don't know the mean and standard deviation, then there's no way that we can use the Chev-Chev theorem. So he would say within 2 standard deviations, so there will be x bar minus, so we're going to take the x bar always be the central. We take away 2 standard deviations to the left. Okay. And then we're going to do the same thing. We're going to do like x bar, and then we add 2 standard deviations to the right. Okay, so we just add 2 and subtract 2 if we know the mean and standard deviation is given from the question. So I'm going to let you know what it is. Okay, so that's important that we do that. Okay, but it looks really complicated, but when it comes to the calculation, it's not that bad. The only thing that you might be wondering, how we're going to get this number? Well, it's coming from his perspective, and at that time he was really smart to come up with that theorem. So at least 88.9%. So this is also another percentage that we need to take care of. Can you hear me so far?
Yes.
Yes. So there were some people who can't hear. Just let me know if you can't hear me clear. Okay. So at least 88.9%. It's going to be the same thing that we're going to take the x bar. But remember, if there are more data set being captured, meaning that the range should be broader. It's kind of be like something greater than that. So instead of take away 2 standard deviations, now we have to take away 3 standard deviations from the left side. Okay, and then we also do the same thing. We're going to take x bar. We add 3 standard deviations on the right. Yeah. So this is the most important thing.
Hello. I'm in class. Yeah, I'm in class.
Okay. So can I mute the microphone a little? I apologize. So there were some sidetrack noises. Okay. All right. So there'll be 3 standard deviations. So that's really important that we know it. Are we good? Yeah, no, I understand because I didn't really mute. Make sure that we're gonna mute the microphone, and so that would be great. Okay, so
yeah. Professor, question. So that's the equation, right? For 75%.
Yeah, so it's
it's the average minus 2 times the standard deviation.
Yeah, and the average add 2 because 2 would be like the step, like how many we step ahead to the left. So we take away 2, and we step to the right, we add 2, and then we're gonna have this interval. Okay, we have this interval. The same thing for 88.9%. So instead of we step 2 steps to the left, but now we step 1 more. Okay, so we step 1 more, And so we can literally claim that, well, instead of, so we're going to have like 88.9%. So for 2 steps to the left and 2 steps to the right, so that would be at least 75%. But if we step like 3, so that would be 88.9%. But you know, I'm gonna give you this format and how we're gonna utilize it on the exam, so don't worry about that. So what we have here, again, that we gotta pay attention to the 2 number that we have. One is 75% and one is 80.9%. The only 2 number that you see on the exam. It's not gonna be something really, really complicated. But again, we need to have some practice and see how it goes. So let's look at the practice questions for chapter 3, I believe. And this is something that we've seen from the note. And so let's say we have the mean score of the math exam, which is 81.4, and the standard deviation is 4.2. Okay, so we're gonna take that example and see what it is. So this is what we have for the questions. Okay, and then let's go for it. Again, that the question will always give us the mean and the standard deviation. So we're going to highlight, we can box the 2 numbers. So the mean, the average will be 81.4, and then the standard deviations was 4.2. It's always be given for this type of question. So I'm going to put them down. The X bar, which is called the average, will be 81.4. Okay, so I'm going to do that. Okay, and then after that, we're going to look at the standard deviation. So the standard deviation is called STD. The reason why I call STD because it's very easy for me to write them down. So that'll be 4.2. All right, so right off the bat, we're going to read the question. So when we see something really weird to read, for instance, we have a Chevbychev theorem. It meaning that we ought to use this 2 equation. Okay, so another keyword that we need to pay attention will be at least 75% for part 8. So at least 75% meaning that, I mean, it's not at least, it can be 75%, you can see that. Meaning that we're going to use the first equation. So we're going to take that at least 75%. I want to change the marker real quick for that. Just want to make sure that we using the proper marker for this kind of competition. Okay, so when it's become 75%, meaning that when we set up the interval, then we have to take away 2 steps from the average, and then we add 2 steps from the average, and then we're going to form the interval correctly. So that being said, we're going to take the X bar, right? Take the X bar, and then we take away 2 times the standard deviation on the left side, and then we take the X bar, and then we add 2 times the standard deviation. Okay, so this is what we need to do. Okay, and then after that, we're going to plug in the values. So the X bar that we have will be called the average. So the average that we found from the questions is 81.4, correct? So this will be 81.4. Right. Why we have to take away 2? Because this is 75%. Why do we have to take away 3? Because it's contain more data set, right? When the range become broader, meaning that there'll be more percentages that fall into that range. So if we see this is 75%, so it has to be 2. If we see 88.9%, so then you have to take away 3 standard deviations. So this is what he's claimed. And y is 2, again, that I have the form for that 1 minus 1 over 2 square. So that'll be 2 step, and 2 step on the left, 2 step on the right. So we got at least 75%. But we're not trying to prove this form because it's really complicated. So all we need to do is just take 2 times 4.2 on the left, and then we take 81.4 plus 2 times 4.2 from the right. So we're going to get the final answers correctly. Okay, and of course that we're not going to do it by hand since we have a calculator. So let me do the calculator real quick and I will let you know what it is. Okay, so again, the calculator that I use is 83. The reason why I'm using this calculator because it's virtual calculator. If you have your own calculator, that's great, but I feel like I never ran out of battery while using this calculator. So that's the reason why I'm using that a lot. If you disagree with this calculator, you can use your own calculator, which is fantastically fine on the exams. But for this time, we're gonna take 81.4, and then we take away 4.4. 2 times 4.2. So remember, we just literally just plug in the value like that. We don't really have to do anything because the calculator will automatically understand that we need to take 2 times 4.2 first, and then we subtract from 81.4. So the final answer for that will be 73. Okay, will be 73. So I'm going to put them down. So this guy will be 73. And I might use different markers to elaborate on the system. So this guy will be 73. And then on the right, we're going to do the same thing. We take 81.4 plus 2 times the standard deviation, which is 4.2. And we got the answers, which is 89.8. Okay, so what that telling us? So this going to tell us that there will be at least 75% of the student will get at least will get between 73 and 89.8 for the exam. So that's really, really important. So let me just put him down. He guarantees, right? So TChevbychev guarantees, we guarantee that there will be at least, there is at least, I wouldn't say like exactly 75%, but I guarantee you that at least 75% of the student have to score between 73 and 89.8. Have the scores between, I should say, have the score. Okay, between 73 and 89.8. So what that means. Are we good? And so again, there will be a little map involving this, and then we're not gonna do it by hand. We just do it on a calculator, and it's basically like a 2-line answer. You don't really have to write down the formula. You just put down the work for the 81.4 minus 2 and 81.4 plus 2 times standard deviation. So then we're gonna get this final answers on the calculator. Okay, so it's more like a 2 small competition for each part of the questions. Okay, and then and so that will be the thing that we have to do on the exam. So regardless, regarding the 88.9%. So we're gonna do this whenever the question gives us 88.9%, then we're gonna do pretty much the same thing. Okay, so let me just at least 88.9%. So this is the thing that we have to look at. Okay, so I might make this a little bigger so we can see through what it is. At least 88.9%. Then we're gonna, instead of we take away 2, now we have to take away 3. Okay, so instead of we take the x bar, you minus 2, then we have to minus 3 because this is 88.9%. Similarly, we take the x bar, instead of we take away, we add 2 compared to 75%. So now we're going to add 3 standard deviation. Okay, so this is a thing that we need to do. So we take the x bar, we minus 3 standard deviations, and take the x bar, we add 3 standard deviation. So remember, the average that we have is always be the same. So the average was equal to what we have was 81.4, and the standard deviation is 4.2. Okay, so this is 81.4 minus 3 times 4.2 because the standard deviation is 4.2. Okay, so let me just use different marker for that so we can see through what it is. Minus 3 times times 4.2. So I want to change back to this marker. Okay, and then similarly, we're going to take 81.4 plus 3, so that'll be 3 times 4.2. Okay, yeah. So remember, the only thing that we need to change will be the step, right? So we keep the mean, we keep the standard deviation, we do not change them. Okay, so remember the average was 81.4 and then the standard deviation 4.2. So we don't change that for both questions. So 81.4, 4.2, but the only thing that we need to change is 75%. So if the question tells us this is set at least 75%, then we have to take away 2. If the question tells us it is 80.9%, then we have to take away 3. So and then we just do the math correspondingly, right? And we're going to do it on a calculator. Remember, we still have to use 81.4. Remember, the average and standard deviation will never change. And then we take away 3 times 4.2 and 81.4. We add 3 times 4.2. So he was super smart. Like he can do, even by 2 of this information from a data set, I almost tell you all the percentage of them that fall within a certain interval. Okay. And that's pretty much the thing that we need to do. So based upon the calculator competition that we got, the first one is 68.8. Okay, so this will be a thing. I'm gonna do that with different marker. So this will be the average, this was 68.8. And then on the right that we do this competition, we got 94. So remember, the range should be bigger compared to that guy's, because of the fact that this range actually contains around 89%. This range contains around 75%. So this one should be smaller range, and this one should be broader, based upon this picture, based upon the calculation. So what that means, we're going to write them down. We guarantee that at least 88.9% of the data set, of the data point of the student, in this case of the student, we have to score between 68.8 and 94. Okay, and 94 on the exam. Okay, so this is how he was smart. Like if you give me those 2 numbers, I can set up the range. I know how many percentage of the people of the data point will fall within that range. So so which helpful, which really, really important. So we can literally check that more than 90% of people who pass the exam for sure, right? And then the rest of them can be somewhere around maybe more than 100, maybe more than 94 or less than 68.8. But the majority of the class, around 90% of the people who have passed the exam and get at least a C minus up to an A, right? 94 will be an A for the class. So this is really, really important. So this generate a very, very important information about how the class performed based upon the average and the standard deviation. Okay, so this is one of the questions. Any concern? Any concerns so far?
Can you do one more example?
Yeah, we can do 2 more. Just want to make sure that we got it. Okay. So let's do question number 9. This is not the correct information. I took it randomly. I just imagined that the US, it should be much less than 54. It should be around 38,000. But for some reason, I just make that 54%, 54,000 regarding the civil engineering. This is a data set that I got from the US salary, but generally it should be much lower than that. But assuming this is what we have from the questions for question number 9, and then we need to deal with that. All right. So, and apparently the keyword that we have to look at will be TChevbychev theorem. Very hard name to read unless you know Russians. Okay, TChevbychev theorem. And I asked so many people, and there was only one person who know Russian not last month, a few semesters ago. And then she told me that we have to put the T in front of it. Whereas my notes, this is a note that I have, I did not have the T. It was the wrong name, so it's unacceptable in Russia. And I was like, okay, I put the T for that. But anyhow, so whenever we have this theorem, then we need to put down the the average and the standard deviation. So the average that we have in this case apparently would be 54,000, but this is not the U.S. salary into the average U.S. salary. It's actually the for a certain few that I just ran on the ticket. So that was 54,000, and then the standard deviation will be 6,700. Okay, so STD will be 6,700. All right. So when we get these two numbers, and then we're going to read the question for part A, there will be at least 75%. So this will be the keyword that we have to look at, and 75%. We're gonna put in there right there. Okay, I'm gonna come back to the marker, at least 75%, right? Okay. So why 75% and 88.9%? Well, because we're only dealing with 2 and 3 staff. We're not gonna deal with like 5 staff or one staff or whatever it is. So we're only dealing with 2 and 3 staff for that, right? It's easy. If you want to deal with more staff, then there will be the form for that. But I do not recommend people to read them. So this is the form. The K represents the staff of the standard deviation. K is any number greater than 1, have to be more than 1. But we're not gonna care much of that. Some people ask me, what is the range if you want to look for like 84% or 76% or 77%? Well, we're not gonna interested of knowing what it is unless I'm gonna give you the formula and then you're gonna solve for K. K shouldn't be the whole number. Remember, we're only dealing with the whole number for K equal to 2 or equal to 3, and that's it, right? So if you want to deal with different percentages, then the K should be different, but we're not gonna care much for that. So again, that we're going to look at the Explorer, and so since we pretty much knowing what it is, so we're going to take this. Okay, so we're going to do like 54,000. We know what it is. We take the average, we subtract. I'm going to change the marker a little bit, right? Subtract 2 times 6,700. I'll change back to this marker. Okay, and then on the right hand side, we're going to do 54,000 plus 2 times 6,700. Okay, so we're going to use different marker to represent, to know the fact that 75 is 2 and 88.9 is 3. As simple as that. Okay, so let me just point it out real quick. Okay, and then we'll just do the math for the calculations. We're going to take 54,000 and then minus 2 times 6,700. So when we do it on calculator, we just do it in one single thing. We're not going to do it twice. So 54,000, unless we make mistakes on it, minus 2 times 6,700, and we got the answers. Okay, and then we take 54,000, and then we plus 2 times 6,700. And then we got another calculation. Are we good? So the answer for both of them will be 40,600. So we're going to do that 40,600 on the left, and on the right, so we're going to have 67,400. So what does that tell us? So this is going to tell us okay, let me just get rid of this. Okay, no, let's use a marker. Okay, so what that means is that there will be around almost like around at least 75% of the U.S. Civil engineering have a salary between 40,600 and 67,400. As simple as that. Okay, at least 75%. But you don't really have to put them down on the exam like that. Okay, of the U.S. salary of the U.S. population. But this is not the real data set. If you want to get the real data set, where should we go to? We're going to go to census, right? census.government, and then we're going to have all the information. So at least 75% of the US population have the range salary, the salary between 40,600 and 67,400. So this is what it tells us. Okay. And
Professor, I have a question. Every time we do the theorem and we get an answer, do we have to write a sentence like that or no?
No, you don't have to. Just want to show what it means. So it's literally tells us that we need to know how many percent of the data set being captured within that interval, that we know it will be at least 75%. I mean, more than 3/4 of the US population going to have this range salary. Given that, these two information is correct, but generally you don't have to put them down on the exam. You just do like this, at least 75%, very easy, right? And then we're gonna put them down and with the equation, and then that's it. And then we do that. Okay, we're not going to write them down like a long sentence like that. It just takes so long to finish the question. So I do expect people to spend around, I would say around 10 minutes for this question. Okay, so we try it again for 88.9. So remember, if the percentage getting bigger, it should be -3. Okay, it's not -2 anymore. So I change the marker. Just want to make sure that we understand that we take away 3 times 6,700. We're going to change back to the marker. And then we do the same thing on the right. We did 34,000. We add 3 times the standard deviations. Okay. So the reason why it's 3 because we have 88.9%. So this is something that we need to keep in mind. 6,700. And then we're going to do the math for that questions for sure. Okay, just want to balance out. Looks good. Now let's go for it. So we're going to take 54,000 minus 3 times 6,700, right? And I can take 40,600 subtract 6,700. I get the same thing. I get 31,900 for sure, 33,900, and then we're going to take 54,000 plus 6,700 plus 3 times 6,700. Okay. And then of course we're going to take this number as 67. We're going to have 74,100. So that's going to be something that we're putting down. And so there will be the final answer for that. I want to change the marker and then rewrite the answers for on this side. So this will be 33,000. Let me just double check that. And 900. Okay. And on the right side that we're going to have around 74,100. So what that means would be at least around 90% of the US. I mean, this is not the true fact, but based upon the information that we got, there will be at least 80.9%, like around 90% of the US population will have the salary between 34,000 and 74,000. So this is what it means. Have the salary between.
Professor, quick question.
Yeah.
Is the final answer going to, should we leave the final answer at 33,900, or we have to break it down again, or that's it?
That's it. That's it. The answer for the Shepherd-Sheff theorem have to be in terms of the interval. So it have to be 2 numbers, like the lower and then the upper bound. So the lower bound for 75% will be 40,600, and then the upper bound will be 67,400.
All right.
For 80.9%, it have to be 2 numbers. Remember, it's in terms of the interval. The interval have to be 2 numbers. One will be the upper, the lowest, and then the high will be 74,100. So
with every question, we're going to get like the A and the B. So you solve for the A and then you solve for the B. So like this one, you solve for 75%, and then you solve for 88.9% too.
Yeah. So that's basically a thing. Always be like that. the exam question will be something like that. Okay.
All right. Thank you.
You're very welcome. And I feel like that's pretty much it. And do you need one more example? It's pretty boring for that. We just know the mean, know the standard deviation, and we know it is 75%. Then we plug in two standard deviation, two step. If it is 88.9%, then we're gonna plug in.
Just so in.
I just plug in three step. Do we need one more example?
Yes.
Yes.
Yes. So let me just make my example. I feel like it's also really fun to have. So the average height. I would say the mean and average are going to be the same thing of the U.S. Population. I would say is so we're going to use the centimeters, just one the universal unit for that. You can use feet, but it's really hard to do with like feet in inches. It's really hard to combine them. Okay, so we can't either. We have to convert feet to inches, then we're going to combine them as a whole, or we're going to have to leave it as centimeters. I would say it's a lot easier. So assuming that the average height of the US population is around 175 centimeters, so that basically pretty much the same, and it's slightly shorter than the Swede and the Sweden. Those two countries like have the highest height in the world. But with the standard deviation, I would say it's really vary and short and tall people. So I would say around 15 centimeters. That is huge. That is great. That is so big. I will let you know. It should be 12. 12 is more reasonable generally. So the standard deviation determine the gap difference between some really low data set and some really high data set. It's really, really important to have the standard deviation bands out from the data set. But anyhow, we're going to find an interval, of at least 75% of the U.S. population fall within. Okay, fall within.
Professor, I have a question.
Yeah.
Are all the intervals, like all the questions are gonna say at least 75 and at least 88,
Yeah,
or does that change?
No, it never changed. Always be like that.
Okay.
Yeah, I want to make my class simple. I just want to give us some idea of what it means. Like, given two powerful parameter. So how are we going to utilize this parameter to actually know almost everything in the data set? Use superset theorem, okay, to find at least 75%. I'm sorry, 75%, and then to find interval. To find that an interval of at least. I should change the standard deviation like to 10 centimeters. Actually, really, really great. Crazy. You have 12. I would say put it maybe 8 centimeter. I feel like it's good enough of the U.S. population fall within. I mean, 12 is really huge. Let me just analyze that later on. So what we have so far for this type of questions that we're going to analyze it, right? So the average that we have is 175 meter, and the standard deviation is 8 centimeter, and we have two keywords, 75 and 88.9%. And don't let those two numbers haunt your mind when you sleep. Okay, step by step. I have so much respect for this Russian guy, so that was why I'm using this example. So what's going on for that is so again, so we're going to write them down to X bar. Let me just use a different marker for X bar will be equal to 175 centimeters. Okay, 175 centimeter. And the standard deviation we call STD will be equal to 8 centimeter. Okay. So now we're going to read the questions for that. So the question is going to tell us that I'm going to make it a little bigger. Okay, since I'm going to finish this question, at least 75% So we'll be going to take the x bar, will be 175 minus 2. I want to change the marker, just want to make sure that we good to go. 2 times 8, correct? And similarly, we take 175, we plus 2 times 8. Okay, I hope that the marker is not too shiny for us, so we can see what it is. Okay, let's just do the calculations. For that, we take 175 minus 2 times standard deviation. It's actually really big. We're going to have 159 centimeter. Okay, it's relatively short for that, but generally we going to have to put them down like 159. And on the right, I think I shouldn't use I should use like something smaller than that. But anyhow, we got to take that 175 plus 2 times 8 standard deviations, and then we're going to have like 191, right? So that's huge. That's really big. It's really tall for that. So it's 191 centimeter. So what that means, I guarantee you that if those two numbers are correct, there will be around 75% of the US population will fall within 159 centimeter and 191 centimeter. So this is what we have given from the questions. So there will be at least 88.9%. So that will be captured a little bit longer or bigger interval. So we're going to take 175 again. So instead of we take away 2, then we're going to take away 3 standard deviations. So we take 3 times 8, right? 3 times 8. And similarly, that we're going to do it on the right, we take 175 plus 3 times 8. Okay, so it's pretty much like that. So we do it again for the calculation. We take 175 minus 3 times A and 175 plus 3 times A. Okay, so I feel like that's going to be the end of the question. So we have the answers, which is 151 centimeter and 199 centimeter. So if based upon if the information is correct, I can guarantee you that there will be around 90% of the US population, we have the height between 151 and 199 centimeters. So this is what it is. Okay, so we can have something like greater than that. I can guarantee you that will be 94%. So after 80.9 will be 94%. So that'll be 4 steps, and then we can have something broader, much broader interval. But generally, we just work on 2 examples, and those are something that we're gonna see on the exam. Are we good? Are we good? We just take the average, and then we take away 2 standard deviation, add 2 standard deviation, and then we same thing for 80.9, and we take the average. So the average and standard deviation will not change. Remember, we always use this 2 number over and over again for both questions. The only thing that we change would be if that 75%, it would correspond to 2, right? And if this is 88.9%, I know it's pretty boring, but it's correspond to 3. But it tells us a lot, right? If this is true, I know it is not true, but if the information is true, if the 2 parameters are correct, for instance, so this is going to be the real thing that we're going to see. Okay, there will be around 90%, 88.9% of the people we have the height between 151 and 199. 199 is super tall, like it's 2 meters. It's almost like 2 meter height. It's almost impossible, but anyhow, unless we're
Good question.
Yeah.
Well, you see how I think I missed the first one. It says the first one is a minus and the second one is a plus.
Yeah,
is that
always.
gonna be?
Yeah, it's always be the same. So the first one we have to take away 2 because we step 2 steps ahead, and then for the second one, it should be the upper bound. So we have to add 2. Right? So we have to step 2 steps to the right. So we're gonna set up the interval correctly for the Chebyshev theorem.
All right. Okay. Thank you.
Professor, in exam, can we just leave it like this without And then you're done.
Yeah, that's it.
Oh, okay.
How long does it take you to finish this type of question? Like 4 small calculations. We do it on a calculator, right? And then that's it. So 4 more, and then you might get around 10 points to 12 points for this type of questions. Maybe more, maybe 16 points for these 2 type of questions. It can be more. It should be 5 points for each, right? So each calculation is 2.5 points. So if you finish that calculation, you get 5 points. You finish that calculation, you get another 5 points on the exam. I feel like it's too much for that, and then let's go for it. Let's go to the next topic, okay? All right, so this is chapter 4. We're gonna finish chapter 4, and then part of chapter 5. Are we really hyped right now? We cover like 3 chapters, but it's generally chapter 4 will be something that we're gonna do here. So this chapter 4 that we work on the correlations, okay, correlation. So, but the correlation, we only work on the linear correlation. So the linear meaning that you have a linear relationship. So this chapter is super important, but on the exam, it's not gonna play a lot of roles because all we need to do will be the scatter plot, and sometimes we just plug in the values and see whether or not it's going to give it the X and Y. So generally, it's not going to be something that we have like a crazy form that we took from the math department. So if we go to like Math 23 BCC, I'm not sure if any of you ever went to this website. It's literally has 3 parts of it, so the syllabus is literally useless. Review sheet also pretty useless for that. The only thing that looks pretty good would be the formula sheet. Okay, so when you look at chapter 4, there will be some crazy competitions, and I would say it's really it's not really easy to digest stuff. All right, so for instance, a few semesters ago, I feel like 5 years ago, it was a long time. When I taught the course, I still basically asked my students to do like aura correlation, but it was super complicated. So I got rid of this part. Okay, so whenever you have a chapter 4 formulas, we're going to get rid of this. It's not going to be on the exam for this. We're not responsible for this competition. Okay. But what we have to be responsible for will be the thing that I have for the notes. So the note that I gave you guys is on Blackboard. It uploaded on Blackboard under the content section. So we click on the content, and you will basically find out there was 2 parts of it. So one would be chapter 4 summary, and the other one would be practice problem from chapter 4. Okay, so this is what it is about, and this is what we're going to be able to understand what it is by the correlation. So what is the correlation? It's sometimes really hard for us to understand. In this case, this is wrong, okay? So the correlation is not relationship between 2 quantitative variables measured on the same individual. So the reason why this is wrong, because it can be more than 2, it can be 3, it can be 4, it can be 5, it can be n, it can be like a lot of them. So so that's really important that we need to understand that the correlation is not just about 2 variables, but the only thing that we do in this class is just only for 2 quantitative variables. So that would be the relationship between 2 or more quantitative variables. So I think I make some mistakes on it when I have the note copied that from the book. So it should be 2 or more quantitative variable. Okay, quantitative meaning that in terms of the numbers, numerical value, so we can literally see what it is. Okay, 2 or more quantitative variables. So let me just point it out real quick. So this will be the values. Okay, this is in terms of numerical value. So we can see the number right away, right? Numerical values. Okay, numerical values. And so that's really, really important that we understand a correlation is not only for two, but in this class that we going to dealing with two variable only, because we're not going to make our class really complicated. Like, well, I give you 5 of them, and then we need to figure out what it means by a correlation. Okay, so that's going to be really, really tragic. For instance, I want to analyze. So I want to we want to look at a correlation between. I might want to make this a little bigger, a little smaller for that. So the correlation between psychology and statistics, psychology and statistics. So this is one way that we can look at it. So there's a lot of correlation, or maybe you want to look at the correlation between math and music. Has been my really favorite subject, to be completely honest. I'm trying to figure out how can we connect math to music. Like, those are two complete different fields. One is from art and one is from something really boring. But it's actually, there's some connection between those two when we look at the beat of the music, depending on the song that we listen to, right? And then can we actually formulate like a certain musical song using mathematical formula. So this is what I usually have to look at it. So some beautiful formula in terms of sine, cosine, if you never heard of it, and then it can actually replace all the beat from the music. And then I want to look at what is the relationship between these two. So I call it correlations. Okay. So if whether or not they have a very weak correlation or they have a very strong correlation. So that would be another way that we can look at it. Okay. So, and we also have something that we correlated. For instance, it is more something that we want. I want to work at. Everybody wants to work at it. So we want to, let's say, I want to figure out what is the correlation between the Tesla stock price, right? For instance, and the gold stock price and the gold price, and apologize, the gold price, and see, and of course that they should have some adverse relationship, because when the stock price going up, the gold price is going to drop for sure. Like, so we want to look at what is the relationship for that, and if they have some consistent trend between the two type of variable, then we can actually make some connection between these two. But this is just the assumption. This might not be true, right? And then you might want to look at how correlations between metaphysics, for instance, and metaphysics that we know what it is, and computer games. So this is also another famous thing that we want to look at, whether or not they can relate to each other and how they visualize gaming skills going to help us understand more about the metaphysics perspective. So this is also like, there is a lot of interesting thing that we want to look at a correlation between these two types. Okay, but in this case that we only look at the linear correlation. So the reason behind that, because this is the most important model. So the linear model. So I always put them down as linear model. The reason why we call linear model, because it's in terms of the equation y equal to mx plus b. Okay, y equal to mx plus b. Okay, so I do not want to remind you from your painful experience where we have to take math 5, and then we just struggle a lot with the slope and then the one-to-set, and those are really, really important that we need to understand what it is. Okay, so the x in this case, we call it the y hat. Okay, the y hat. So for instance, can I use Apple price in the market to predict, let's say, popcorn prices that we have to buy in the same supermarket? So for instance, those are really, really interesting facts. So when we trying to use something to predict another thing, so we call that guys as independent variable. Okay, so x in this case that we call independent variable. So that's really important. Independent variable. In fact, there are only 2 of them, but we want to deal with 2 only, because it just make our class simple. Okay, we can have more, but it's more like the multivariate statistics. It's pretty complicated that we want to look at it. So when we use x, right, we use x to predict y. So x have to be independent, and all the value of y, meaning that all value of y depends on x, right? All value of y depend on x. So we call y as dependent variables. There's always be something like that. So this is the thing that we're going to put them down as dependent variables. So I want to change the marker a little bit. Just want to make sure that we follow through what it is. Okay, so so this is what we call dependent variable. Okay. All right, so those are the thing that we need to know. It has to be the linear model, and it has the equation y equal to mx plus b, where m will be the slope, and then the b would be the one-intercept. But you don't really have to like worry too much for that. I'm not going to give you a review of what the slope means and what it is by the one-intercept. But the most important thing that we need to realize, there will be two big, drastically different between math and statistics. So this is what it means by math, okay? If we understand what it is, then we're good to go. The math, or probability generally, so we're going to go to chapter 5 later on, and then we're going to see what it is, what I mean by probabilities. So for instance, the map, this is what a map looks like. So the goal of the map, they're going to generate the line, for instance, and for instance, this line will be y equal to 2x plus 1. Sorry, y equal to x plus 1, okay? So this is what it means by math, okay? This is what it means by math. I will put them down real quick right there. So this is math and versus statistics, okay? Okay, so most of the data scientists, they have to be like the math major as well, because they need model. So where the model coming from? The model coming from the mathematical perspective. So when we look at the line equation, we can literally check that. We can figure out, if you give me that equation, then I'm going to give you the point, right? So I can figure out how many point in there, right? So I can give you 1 point on this and 1 point on that on the same line, and 1 point on this, and another point on the other side. So it doesn't really matter. It's just fixed, right? So all these points can be figured out. If you give me the certain value of x, I can give you the corresponding y values. Okay, so this is what it is by the mathematical perspective. All right, so this model we call a linear model, but in statistics it's drastically different because of the fact that it's not like mathematics. Mathematics is more theory. It's more like theoretical perspective. It's pretty boring. It's more like religion. Okay, I give you the line, and then you give me the slope, 1-7, and what I mean by that? Well, I can give you 1 point and any point, all the point ladder on the same line, like infinitely many points, because this is a continuous model. But in statistics, it will be completely different. Like, I'm not going to give you any model for that, right? I'm going to give you a bunch of data sets. So I'm going to throw in like 1 point, 2 point, and 3 point, and 4 point, and 5 point, and 6 point, and 7 point, whatever it is, right? And maybe 8 point. So your job, the statistician job is to do what? We're going to use the map. I mean, in this case, will be the linear model to predict that relationship. So what's going on for that? We're going to look for, we need to sketch a line, of course. We're going to sketch a line, of course, that will be the best fitted to all of these points. Okay, so we call this line will be the regression model. So in other words, I don't know if all of these points going to ladder on the same line. Usually not. Very likely. You don't see all the points that ladder on the same line like mathematics, because this is pure math. This is more like, well, theory. Theoretically, they have to be ladder on the same line. So we call the line equal to y equal to x plus 1. But in statistics, all of these points should be scattered away. But our job, the statistician going to have the job to figure out what is the model, what is the line, what is the linear model that can fit all of these points with the least error, with the least gap between this, okay? So this is what it means by statistics. So the data analysts, they're going to do that. The data scientists, they combine math and then they use the best fit model to do so. The data analyst is more like so okay, so what kind of model? Okay, I'll take that. But the data scientists, they can also invent the model. They can also change a certain perspective for that to make it better. So the data scientist is more like a little harder to get at. So generally, what we need to do is we're trying to figure out a line. Hey, what is this line? What is the line that we're looking for that going to fit all of these points with the least error, with the least gap between each point to the line? We call statistics. Okay, so generally you throw me in a lot of data set. Remember, statistics means that we have to deal with the data, right? So it is more practical perspective, practical things. Okay, and this is more theoretical. And of course that we can have only for theory, we need to do the practice. So how we're going to do that in practice will be statistics. So you give me a bunch of data set, I'm going to give you the line that will be the best fitted for all of these points. So we call statistics. All right, so generally this is also the thing that we have so far. And what is the correlation? So we're gonna have a certain thing right there, and I'm gonna copy and paste and analyze it whether or not we have positive or negative correlations. So we have 6 graphs. Generally, we don't see the last C and F graph because it's just something that we do not want to deal with. C and F. Okay. All right, so this is what it means. So generally, if all the points ladder on the same curve, that we can tell it is a perfectly correlated model, right? So it's never happened in real life because we can't have all of these points line up on the same straight line. That's impossible. Okay, so this one will be perfectly correlated, negative correlation. So anything that's going down from the left to the right, this has negative correlation. Okay, so this is a perfectly negative correlation. Negative correlation. But this is only happened in mathematics, but it's never happened in statistics generally. But the more common map, more common curve that we're going to look at is here, right? Because we can literally check that. Remember that we do not connect them. Okay, we do not connect those points. So this is what it means by negative correlation. It has a pretty strong correlation, and it's also negative, so it has to be negative correlation. Okay, negative correlation. And if you see something like that, for instance, there's, regardless how you're gonna sketch it, how you're gonna find the point, and it doesn't work, right? So you can either go down or maybe you go up right there. So it doesn't work no matter what. So it doesn't really have any correlations generally. So we would say there's no correlation. So where the data set like it's not going up and down, so we have no correlations. Okay. I mean, it might have different correlation, but it doesn't have any linear correlation. Just want to make sure that we're not like misunderstood what we have right there. So this is no correlation because of the fact that it has no linear correlation. No matter how we're going to sketch the line, it's not going to fit all of these points. So similar to that, this is half circle. It had a half circle correlation, but generally there's no linear correlations because we cannot fit in any line that match all of this. Okay, so that's important that we need to know. And so and then you can literally check that no matter you point the curve right there, or maybe you go like this, it just doesn't work. No matter what it is, it just doesn't work for that tragic moment. All right, so but similarly, when we have the curve going up like that, so it has a positive correlation. Remember, we're not going to connect all of these points. We just make a straight line to elaborate that relationship. So this one, we're going to have a positive correlation. Yeah, and I'm going to put it right there. And of course, when you can have all the line that they go up on a straight line, but it's never happened in real life. How is that possible? Like, we're gonna figure out like two type of data set they're going to have a perfectly positive correlation? That's impossible, right? It's only assisted math. There is no such a way that we can have this happening. So this is perfectly positive correlation. Okay. Yeah. And that's pretty much a thing. So whenever it's have like the curve is going up like that, okay, it's going up like that from the left to the right, okay, it's going up from the left to the right, then we call this as a positive correlation. Okay, let me just point it out real quick. So this one is positive correlation when you make a scatter plot. Okay, so whenever it has like the trends going down from the left to the right, and apparently we have a negative correlation. Okay, so that's important. Negative correlation. Okay, so because so you need to explain it on the exam because it's trends up. So I use the word trend because there will be some points going down, but it doesn't matter as long as the majority of the points are going up, then we're good to go. And in this case, because it's trends down, in other words, it tends to go down, meaning that it trend down. Or you can just say it tends to go down, and so I understand what it is. Okay, so this is a thing that we need for determining the relationship. So now we're going to deal with a certain practice problem and see what it is. So the most important thing when we look at this chapter is to understand what it means by the correlation, the difference between math and statistics, and when we're dealing with the linear model, what is the independent variable? Because we used all the value of x to predict the y. And so meaning that x will be the independent, all the value of prediction on the y will depend on the x value. So this is really, really important. Okay, so we need to know which one a dependent variable, which one independent variable, and after that will be the correlation. Okay, so now we're going to be working on with some example, I believe, and yeah, this we're gonna skip all of that. Generally, we're not really interested like knowing what type of the coefficient of determination, whether we use that to determine whether or not it has a strong or weak relationship. So we're gonna skip all of that. So we're gonna go to one example and see what it is from our notes. So that example is relatively important. So assuming that there was a survey asking 7 people who are willing to spend time reading books. So what I'm doing is that I'm going to be working on with 7 people. Okay, so those 7 people are actually have different ages, of course, right? So I want to make if there is some connection between ages and the hour they spend reading book. Usually that we have a feeling like people who get older, they might read more because they have more leisure time. It might not be true in that example because this is an example that I took a long time ago, and it might not be a good reflection of the ages and the hours they spend reading book. But generally, this is what we have right there. So if we ask, there were 7 people, meaning that n equal to 7, right? So we have 7 data set.
I'm sorry, what number is this question?
This question is from the note. There's no number for that.
Okay.
It's from the note that I put it on the age and in the
So
app.
it's not from the summary?
Yeah, it's not. It's from chapter 4 summary. And so I would like to ask, like, assuming that there is a survey asking 7 people who are willing to spend time reading the book, and we want to see if they get older, should they read more or should they read less? Or did they, oh no, okay, so we want to look at it. So the X will be the ages, and then, so we want to determine the relationship between age and the hour they spend on reading books. Age and hours. Okay, number of hours. Okay, so that's really, really important that we need to know what it is. So the X always be the first thing. So the age cannot be like, the age cannot be like a second line because we do not have like 10 years old, 11 years, 2 years old, or something like that. So the Y should be the number of hours, right? Usually on the exam, it will be determined relatively easy for all of us. So this will be the hours and this will be the ages. Right. So you want to see whether or not the connections between the time that they read the book, they spend reading book, and how old they get. So this is what we call for the ages. Okay. So we have 7 data sets. So let's say a person with 20 years old spend 7 hours reading book per week. The person who is 25 years old spends 5 hours reading book per week. A person who is 40 years old, 40 years old persons spend 4 hours reading books. So this is just a few examples that we have right there. So if I would say a person who a 55 years old person spend 2 hours reading book, and 15 years old person spend 11 hours reading book. I'm not sure if that is the correct answers, but anyhow, so the first step that we need to do for that example is to make a scatter plot. It's always been a question that being asked on the first exam and the final exam. The scatter plot will be part of it, and there will be around 7 points for this type of questions. Okay, 7 points, it's not quite hard for all of us to get the point on the final exam. But of course, on a first exam, it should be more. It can be 10 points when you make the scatter plot on the exam because it's a very, very important chapter. But it's really, really easy to get a point. So I would make sure that all of us are able to get through all the scatter plot point. I would say this is the second easiest problem that you might have on the final exam. So make sure that you're not going to lose some point like that. So the first step that we need to do is you might want to arrange the data set in orders, but when you rearrange it, we got to be careful with that. So let's say 15 have to go with 11, right? So this is the youngest girl or guy in this set. And then after that will be 20. So 20 have to go with 7. Right? You can't not just arrange for X and then we keep the Y going to be the same. No. So 55 have to go with the 2 hours, and 28 have to go with 6 hours, and 40 have to go with 4 hours, and 25 have to go with 5 hours. So we can arrange them in order so that I can easily see what it is. I am the person who do not want to do additional step, even if the step is really helpful. I feel like some of us, some of my pastors, they told me that arranging the data set is going to help us a lot because I can see through what is the biggest data set and what is the smallest data set right away. So I can arrange 15 and 11 going first, and then 20 to 7, 25 to 5, 28 to 6, 32 to 10, 40 to 4, 55 to 2. It looks amazing when you arrange this, right? So it's just easier when you look at a data set. But for me, we don't have to. But we need to know which one will be the smallest. So the smallest will be 15, right? So put them down, this guy will be 15. Okay. And then I want to make that a little smaller so that I have enough space for that. And then after 15 will be, the biggest will be 55, right? So we can see that this is the biggest value. This is the smallest value for X, and this is the biggest value for Y. You don't have to, you don't have to do that if you know how to make a scatter plot, the smallest values. And this is the biggest value for X for ages, right? This is the biggest. Okay. Okay. So so again, the vertical axis will be the X, always be the X, and the horizontal axis always be the Y. So I just want to make sure that we are working out this one correctly. So the age always be the X, and then the hours they spend reading books always be the Y. Okay, hours always be the Y. So it's really, really important. So X will be the X on the horizontal axis, and the Y will be on the vertical axis. If you mess them up, then we're going to get point deducted, and of course you're going to get the entire scatter plot wrong for sure. And make sure that you're not going to mess up with X and Y coordinates. So remember, the coordinates X and Y have to be X going for the horizontal, and Y have to be the vertical axis. So we're going to come back to the problem where we're going to have the biggest value of 55. So we're going to put them down. This guy will be 55 right there. It should be around the corner. So I do not really put the scale into account that much. As long as you can give me a relatively good scale, I give you full credit for that. Okay, so this is for the X, the maximum for that. So we can divide them, the chunk pieces. So we have 20, 25, 28. So we have 20 right there, right? We have 20, and we put them down. This one is 20. And then we have 25. Okay, we have 25 in this case. And then, and after that, we have a certain thing. So you don't really have to like do all of that. As long as you give me a relatively good scale, I give you full credit for that, okay? And 25, and then 28, and then 32, and then 40. So 40 should be around the corner right there, right? 40.
Professor?
Yeah.
That n equals 7. I understand the 7 is the 7 people, but what's the n? Like, is that the letter that?
And no, and just the number of the data set, the number of people.
Okay.
In this case, so n equals just, usually we use, so when we use the sample, and then we always let the small n represent the number of the sample data sets. So for instance, if I capture 7 individuals or 7 people, so n would be 7. It's just something that we have from the data set as well. Let's say I give you 5 data set, I ask you just to compute a standard deviation, so n equals to 5. It's just the notation that we usually use for the sample size.
Thank you.
You're very welcome. So, and now we're gonna have this as 40. So a lot of you might be asking me, does it matter if the gap between 25 and 40 are not the same as 40 and 55? Well, it doesn't really matter to me that much, to be completely honest, right? I still give you full credit for that, but you don't have to get the exact values. Like 40 have to be like the same gap. So you know the difference between 25 and 40 is 15, and then 40 and 55 also be 15, right? But the only thing that mattered me a lot on the exam is if somebody put 40 before 15, for instance, if you put 40 right there, okay, if you put 40 here, I'm literally give you no point on this question. Remember that, because 40 should be after 15, should be after 25, and before 55. You can't put like 40 in front of 15. That is the wrong answers. So making sure that we know this trick. And 25 should be after 20. So we have, so all the value that go to the right will be increasing, correct? So 25 cannot be between 15 and 20. So you gotta be really careful for that. And similarly, 55 always be 55 the biggest value, so it has to be on the right. This is the biggest value they can see on the questions. All right, so we do the same thing for y. So the smallest value is 2. Remember, the y and x doesn't necessarily have to have the same scale. Some of you might be thinking, well, okay, this is 15, so 2 should be like below that. No, the y, x, and y do not necessarily have to have the same scale. So we just do the new scale for y. So in this case, that'll be 2. Okay, and after that, we have 4. We have 5, we have 7, we have 6, we have 10, and we have 11. Okay, so it doesn't necessarily mean that, well, 2 have to be like something compared to the x, not necessarily. Okay, but 2 have to be the lowest point, because the 2 hour will be the smallest data set respect to the y. So I'm going to put 2 right there. Okay, just make it scatter plot correctly. All right, so let me just point it out real quick. So this is the biggest for y, smallest for y, and this is the biggest for x. I'm sorry, biggest for y as well. I'm so bad. So this is the smallest, and this is the biggest. Right? When you travel in the opposite direction, you're definitely going to see that they have negative correlations. Okay, so this is the biggest. Let's check them out. So now how can we make the scatter plot? So we're going to use the point plot for that, right? So 20 have to go with 7. So 20, so this is 2, 3, 4, 2, 4, 5, 6, 7. So this is 7 right there. Okay. So 20 have to go with a 7. So this is one plot. All right, so it seems like I do not have a good plot points. One plot right there. Okay, so now 25 go with the 5. So 5, 7, 6, 5. So it should be on the bottom part. So that would be another plot. Are we good? And then we keep doing that. So 40 have to go with 4. That will be another plot for that. And then 28. So 28 should be between that, right? So 28 right there. Have to go with the 6. Okay. 55 have to go with 2. So this is another plot. So 55 have to go with the 2. And then 32 have to go with the 10. 32 have to go with the 10. All right. It looks like a little bit off for me. And finally that we have is 15 have to go with 11. So 15 going right there. All right, so how many plots do we have? So we should have 7 points on the list. So 1, 2, 3, 4, 5, 6, 7. Okay, so make sure that we're not going to connect them. Some of you might be like, all right, I have a lot of fun drawing a Pokemon on the picture. Please do not do that. I would take away point by doing so on the. I'm sorry?
No, that's funny.
Okay, so make sure that some people they draw this thing, and then they feel like, well, okay, I have a really good imagination. I have a lot of leisure time during the exam. People just finish it in a very short time because they know what the question looks like. And then they give me some roses on the side, and then, I don't know.
Business.
Yeah, so don't try to show up your drawing skill on the exam. Take away point, I get jealous. I don't have that skill, right? You can see that my picture drawing it doesn't look really cool, but you guys can be a good visualize, have a good visual.
Excuse me, Professor.
Yeah.
But why do we have to skip some numbers? Like on the Y, you didn't put all the numbers. I didn't understand it.
Oh, so the number is here. So how many number do we have for Y? 1, 2, 3, 4, 5, 6, 7, right? So we should have 7 numbers. So the first one is 2. The smallest value is 2. And then after that, we have 4. But I'm a little lazy. You don't have to put them down. I understand it. But in fact, if we want to make a good scatter plot, it has to be 4. And then
yeah, that's what I mean. Can we just put all the numbers accordingly?
yeah, of course, but I don't have enough space, right, for that.
Oh, okay.
Yeah, of course you can put all the number, but you know
And
if
same
we
thing
have.
with X?
I'm sorry.
Can do the same thing with X?
Yes, absolutely. If we have enough,
Okay.
I mean, putting down all the number is the thing that we have to do, but I don't really put a lot of focus on that, right? Because sometimes people are not feeling well to put that order number. So, and then I don't have enough space because my graph is pretty small. And then,
Yeah, I just feel like putting the whole numbers will make it more easier to plot the graph.
and make it a little easier for us to look at it. I absolutely agree. But it looked like a big mess when you see that, when you have a lot of numbers that ladder on the same line. But
Yeah.
so that's a reason why I always use like the smallest and then the biggest values, and then the rest of them I just estimate them. Okay, estimate them. But making sure that 10 have to be below 11. We can't have like 10 going up for that, right? So you have to be in this order: 2, 4, 5, 6, 7, 10, 11. Or we can have 15, 20, 25, and 28, 32, 40, and 55. So this is a thing that we need to put in there, I think. But you don't necessarily have to put all the numbers unless you have enough time and unless you have enough space for that, unless you want to be specific. But when I look at the graph compared to the thing that I have on the model, and then we go to go. So when you look at this, it's this is a thing, correct? This is 1, 2, 3, 4, 5, 6, 7. I never make this a line. I never make any connection for that. But when we go to part B, the part B will be asking us whether or not they have a linear correlation. This is where what is that correlation between them? So if there are any correlations?
Yeah.
Is it positive or negative or none? Positive correlations, negative correlation, or no correlation?
Is it negative?
Why is negative correlation?
As I said, I think it's negative because it's not joining. You can't make a straight line out of it.
We cannot make all the straight line for all these points. We just need to sketch a line to elaborate that relationship. Do we all agree that it trends down? The line is going down. All the data sets are going down.
Yes.
Yes or no? I mean, there will be some points going up, but the trend is more important. You can see that there was some point like 32. It's spent 10 hours, 10 hours per week reading book, but this is only a few exceptions. But the majority of the points is going down. Do we agree?
So it's negative.
So it have to be a negative correlation. Okay. Negative correlation. Are we good?
Yes.
So some of you might be thinking like, well, 1 point is going up. All right. But the majority of that is going down because, so we need to explain it. I do not really put a lot of focus for the explanation, but we have to do so because it's part of it. I agree because it's trend down. All right. You have to put them down or because the data set's going down from the left to the right. So just want to make sure that you put them down from the left to the right. Right, it's going up from the right to the left, but you have to put more specific on what we're doing right there. So from left to the right, and that is all we need to do. That's it. And now the part C of the question, it might be asking us, it might give us the linear correlation for that. Let's see what the part C looks like. Okay.
So on a quiz or test, I'm sorry, Professor, we have to put whether it's a negative correlation and where it's like it's coming down from.
Yeah. So for instance, if the point is going down, we need to say negative correlation because it's trend down. That's it. In fact, I will never give you this question on the exam. Okay. There's no correlation, but it's never. I have been like doing all the exams, like have been teaching for like 6 or 7 years or coming up 8 years. So literally no correlation does not exist on the final exam. Okay, so it will be either positive or negative. Just want to make sure that there will be 2 topics on it. So you need to say whether it's positive or whether it's negative correlation by looking at the graph. So no correlation will not be on the exam.
Okay.
All right. So make sure that if it's going down, meaning that it has negative correlation. If it's going up from the left to the right, it has positive correlation.
Sorry, you just answered it.
Yes.
If it's going up, it means it's positive, but if it's coming down, it's always negative.
Yes.
All right, okay.
So assuming that we have the line equation, so the part C is give us y equal to, let me just read that real quick. The y equal to negative 0.8 x minus 12, y equal to negative 0.8 x plus 12. Okay, so this is the thing that we want to look at and know what it is. So this is the predicted equation. So this is how people sketch the line. Okay, and they figure out that relationship. Of course, we're not supposed to do that because it's just too much for all of us. So assuming that we want to predict the score if that person is 20 years old, for instance, if, remember, the questions always give us the x to predict the y, it cannot do the opposite, remember, because you have to read that slide. Okay, we have to read that slide. We always use the x to predict the y. This is the equation for independent variable x to predict the y. We cannot go backward. Some of us ask us like, what happened if the question gives us the y to solve for the x? The answer is absolutely no. The questions already give us the x, and all we need to do is plug into the y of 20 and to see what it is. If that person is 20 years old, how many hours should we predict that person to spend time reading books? So we're going to take negative 0.18, then we multiply by 20. So I'm going to change the marker for that. Just want to make sure that we are getting this right. Multiply by 20, and then we add 12. I'm going to change that to a different marker as well.
I'm sorry, Professor, where did you get the 0.18?
I'm sorry? Where do we get what?
The 0.8.
Yes.
From the questions.
Oh.
It had to be from the questions, right? We're not responsible for getting this line. It has to be giving us. If the question doesn't give us, we can skip that. If the question gives us the line, then we have to.
I didn't see that also.
Right? We have to plug in the value for that. So assuming the line equation. So assume meaning that the question gives us like the line equation, which is y bar y hat equal to negative 0.18x plus 12. Okay, so this is a thing that a question gives. Are we good? Plus 12. And how can we do this calculation? So we're going to take negative 0.18 times 20 plus 12. What is the answer for that? So negative 0.18 times 20 plus 12, and we got the answers, which is 8.4. Are we good? We'll just do this single calculation like that on the exam.
Professor, sorry, where did that 0.8 plus 12 come from?
Coming from our mind, coming from the programs that I use, given by this point, so assuming that we have all of this bunch of data set, then we're going to utilize this data set to figure out the line equation. But of course, we're not learning how to do that. The reason behind that is it's a really complicated process, right? So we just skip them. The question is going to give us the y hat equal to negative 0.18x plus 12. And after that, the question will be asking us if that person has the age of 20, in other words, if that person is 20 years old, how many hours should we predict that person to spend on reading books? So in this case, per week, in this case, that we can figure out that person spend more than 8 hours reading books based upon this model. Does it make sense?
So the question is going to give us the numbers, 20.
Yeah, so the question always give us the equation and always give us the x, and all we need to do, we just utilize the x, just plug in the value, and we solve for y. Are we good? Okay. So it seems to be like a little complicated. So let's try a few practice problem and see what it is. All right. I mean, I know it was a little bit challenging for us, but when you look at the practice problem, you're going to see what it is. So let's look at the practice question for Math 23. And it's uploaded on Blackboard. You can see them.
I
Yeah.
have a question. So we got 8.4, but on the question it says 15.6.
Is it 15.6?
That's only if you don't add the negative, it's gonna be 15.6.
Oh, I apologize. Sorry, I make a typo. I apologize. It should be 8.4. I'm gonna change that real quick. Yeah, I think I put a negative when I do the math. Sometimes I have some eyes problem, and then when I plug that in, I just do like this. I apologize. It should be negative. The negative collision have a negative slope. You're right. This is the wrong answer, so I apologize for that. It should be negative 0.18 times 20 plus 12. Yeah, I'm gonna fix that and I'm gonna repost it on Blackboard. So I apologize for this. Okay. Yeah, sometimes I just forgot the negative terms because of the negative side was so small. Sometimes I can't see through what it is. So yeah, I always have some eyes problem with that. Yeah, so I'm gonna change that to 8.4. Yeah. So let's do some practice problem and see what it is, and let's go for it. And then we're going to practice a few questions. Let's say we're gonna do question number 2, I believe, and let's see what it is. I'm gonna copy and paste for that type of question. Okay, so remember, if you practice all of this question, it should be fine on the exam, go on to you, and the final exam as well. It cannot be harder than this, like 100% sure. All right, so this is the manager of a company suspect that the demand of a product. So that person want to look at relationship between, I'm not gonna read that, disposable income and the sales volume. So disposable income was something that I cannot see the board. Can you see the board?
Yes.
Yes and no. Okay, so maybe one person who couldn't see the board, make sure that we're gonna turn on when you turn on the phones or the computer laptop, I think it's just automatic. I'm not sure why. Okay, so we want you find relationship. So usually that if you have more sell and we're going to have more income. So that's generally the thing that we're going to look at. So so this is what we have for we want to look at the annual disposable income and the sale volume. So if you make more sale, of course the income going to going up really quickly. In terms of thousands of cases and the income in terms of the million of dollars, right? So we look at the 5 different data sets. So n equal to 5. Okay, so y n equal to 5, that represents the number of data set that we have on the list. So the first step that we need to make is scatter plot, right? The scatter plot will be something that we're gonna do it right here, and then this question was relatively okay for us, so I'm going to make the scatter plot right there. All right, my mouse started to act up a little bit, but it looked cool. So again, that the X represent the income because this one is going first, right? This is the X. So X always be in the first column. I'm sorry, on the first row. So remember that X always be on the first row. And then the Y will be the cell. Will always be on the second row. Remember that X and Y. So X will be on the first, and then the Y gonna be on the vertical axis. Okay. So now we're going to have like 10. So 10 will be here. 10, 20, 30, 40, and 98, right? So remember, 98 cannot be in front of 10. That makes no sense or anywhere between that. Okay, so this is 10. You don't necessarily have to put them down, but just want to make sure that we understand what it is. 30 and 40, and we have the last one is 98. And we also have like for for this line, we have 2, 3, 4, 5, and 12. So we have this is 2, right? And this is 3, this is 4, this is 5, and this is 12. Are we good? So you can put in if you want to, right? You don't, but you can at least give me like the smallest value and then the biggest value. If you want to take care of the rest, of course you can. If you don't want to, you can just leave it like that. Okay, so 2, 3, 4, and 5. Okay. All right. And now what we need to be doing is we're going to connect them. So 10 have to go with 2. So we have to get one plot for that. Okay. And 20 have to go with 3. And 30 have to go with 4. 50 have to go with 40 have to go with 5. And 98 have to go with 12. Okay, and then we're not going to connect them. We're going to make a plot for that. Okay, so remember, this is the scatter plot. What I mean by the scatter plot, all these points have to be in terms of the point, the scatter, right? So it has to be this, you can't make any connection between those things. So we're going to put a straight line for all of that, right? So we have 1, 2, 3, 4, 5 points. So what does that represent?
We had a positive line.
Yeah, so ignore, you do not have to plot the square like whatever it is. So ignore all of that. The first step, you make a scatter plot. The second step, you're going to tell me whether or not it is a negative, a positive correlation. So this is a positive correlation because of what?
Because it's going up and up to the right.
It's going up. It goes up. I would say it trend up. It's feel like it's a better,
yeah.
It's trend, because there will be some point going down, possibly, but the most important thing is the trend is continue to go up. So it trends up from the left to the right, from left to right, and then we're good to go. And this is a good explanation for that. Okay, finally, we're gonna look at the part B, and then let's give us the line equation. You don't have to plot them on the curve. Remember, I do not ask us to spend time working on for Math 5, because I feel like Math 5 is challenging, and then we suffer enough for those classes. So we just literally just put them down the line equation. So we have the y hat. I forgot the hat right there for some reason. I don't know what happened. It is a prediction of the cell given by the income. Okay, so we're going to put them down as y equal to 0.11x plus 0.7. So I'm going to change to a different marker. I just want to make sure that we read it through. And then, okay, so now what's happening? The questions will always give us the x. So how can we figure out the x? The x has to be given, because the question, if the question gives us the line equation, the x always be given. How can I figure out the x from these questions?
X is 10.
No, x is here.
You have to get x by itself.
Yeah, so x have to be equal to 80 million.
Yes.
This will be the x. It always be given from the
80 million.
80 millions. But this is the unit for that is in terms of the millions, right? So we're gonna have like that, $1 million. So x equal to 80, correct? So we can literally check that for x in this case will be equal to 80.
Yes.
So the x will always be given in the question?
Always be given. If we don't have the x, how can we yeah. Okay, I can't change back to the marker for some reason. Okay, so this one x equal to 80, correct? How can we solve for y without the x? That's impossible, correct? So it has to be given from the question. So
Professor,
yeah,
the x and the y must be given.
no, the equation has to be given, right? If the equation is given, then the x always be given. So alpha y will be 0.11 times 80. Right? I'm going to change the marker a little bit. and then I change back to the to this marker, and then we're gonna have multiplied by 80. Okay, and plus 0.7. So how can we do these competitions? Should we do it by hand? No, right?
So which one are you doing? The B?
The B or C. Do it all of that.
Okay, all together?
All together.
Okay.
We always have to follow a step. The first step, we make a scatter plot. Second step, we tell me whether or not it is positive or negative correlation. The last step, we're going to look at the line, the equation from the line, and then we use the X to plug in and get the final answers. So we're going to take 0.11. It's positive correlation, so the slope is also positive, times 80 plus 0.7. What do you get? 9.5. Are we good?
Yes.
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 Am I doing that too fast? Sometimes, if the question doesn't give us this equation, we just stop at the step 2. Like after we're telling us it is positive for correlation, and then we're good to go. Right? We do not have to do it furthermore. Questions like this. But if the question gives us the line equation, the question has to give us the X. So the X has to be given. So we have to read the questions, and then you plug that in to solve for the answers.
Professor.
Yeah.
Can you please do the X and then the bottom one there, B and C again?
Can we
go over it again?
Can we go over X again?
Yeah. Yeah. I think
the X is given. The X is given from part C generally, or anywhere can be part B or part C.
It's so.
Yeah. So X equal to 80 million. So I want to look for the cell volume will be expected. So I want to predict the Y. I want to predict the Y, the cells given the income equal to 80 million. So when X equal to 80, what is the predicted cells? So that'll be 9.5 thousands of cases. Okay, so this is what it means. So X will be given, the Y will also be given. Our job is to plug into X and solve for the Y. Okay? Are we good?
Yeah, we good, thank you.
So we're gonna do another question for that. I would say we're gonna do question number 3. After 2, we're gonna do 3. I feel like it's fair. Okay, so let's go question number 3 right here. And then going to the last line. All right, so what the question is asking you to do, you're gonna make a scatter plot and tell me whether it is positive or negative correlation. Are we good?
Yes.
Okay, so I may want to copy that later on. All right, so I want to have some space for the next question, do one more question, then we're good to go. So this is the data set, and then we have like 4 different values. So n equal to 4, and we should predict to have 4 points on the scatter plot because n equal to 4, right? And of course that we're going to do that real quick. So this guy, we have the X. It doesn't tell us what it is, like pension. So the pension would be the X. I'm not going to put them down. I just put down X, and this is Y. So for simplicity, okay, you don't have to give me what is that. We can let me know like percent of taxable income, which is for Y, and then the pension will be the X for that. So we have 4 points, so n equal to 4 in this case. Okay, so and that's it. And then we're going to have some points right there. So so the smallest value is 3.3, right? So this is 3.3. Okay, and then I want to make that smaller. Just want to make sure that we have space. And then the next point that we're going to look at will be the largest. So that'll be 12, correct? 15, I'm sorry. So 15 will be the largest value. And after that, we're going to have like 9 and 12. So 9 have to be here. So 9 is here and 12 is here. Okay, I'm going to put them down right real quick for that. So 9 and 12. Okay, so 15 was a little bit off. So we're going to put it right there. Okay, so, and we take care for y as well. So y is 7.2, 5.5, 9.1, and 5.2. So the smallest value is 5.2. I'm going to put it right there. Right, so this is 5.2. And then the largest value is 9.1. So we're going to put it 9.1 right there. Okay. All right. So now the next would be 5.5 and 7.2. So this is 5.5 and this is 7.2. Okay. So we're going to put it right there. So we got to be really careful for that. And after that, we're going to make a scatter plot. Okay, so the scatter plot, so 3.3 have to be the corresponding point, right? So 3.3
The 9.1.
The 9.1, very good. We can't just do like 3.3 and 5.2 and they keep doing like that. It's make no sense, right? So yeah, so 3.3 have to go with 9.1s. I'm sorry, yeah, 9.1 had to be on top of that, right? And then 12 have to go with 5.5. So 5.5 is it's right there. 12. It doesn't necessarily have to be in order, but you can do it in order. I feel like it's easier. So 9 have to go with 7.2. Right. I can go with any point as long as I get the x and y correspondingly correctly. I can go with any point I want to. Okay. And then finally that we have 15 go with 5.2. That would be the lowest point. What do you think?
Negative.
I'm sorry?
It's negative now.
Negative
Negative
correlation.
correlation.
Yeah, so make sure that we're not going to connect all of this point. Make sure that you're not going to draw me picture on the exams. And we just put them down right there. And then you call this as a negative correlation. Why?
It's turning down.
It trends down. Very good. So can you do that on the exam? So this is a negative correlation because the data sets are trending down. Okay, so, and we need to pay attention for that. There's no line, there's no y go to whatever x plus b, right? Whatever it is. So we just stop right there. We do not continue on the calculation. That's it. There's no calculation on this for that example. Are we good? That's it?
Yes, this one was easier.
This one is easy. Everything is pretty easy because it's all, if the question gives us the line, it's always give us the x, you just plug that in so you get the final answers correctly. There's no, I would say there's no like hard feeling for that, but generally I'm gonna go with 100%. So we do one more questions and then we good to go, correct? One more question for that real quick. Okay, copy and paste, just want to make it easier. Oh, I never seen that before, this question. I think I never done that, but let me try for that questions. All right, so let me just copy and paste. All right, so this is the questions. I don't have enough space, so let's see. So make us, I'm gonna draw a line for that real quick. Okay, so we have two different questions. So the first one is, you want to the pony, the age of the pony, and the weight, right? Wow, that's interesting. So people, the pony get older, it should have a fewer weight, I would say. I'm not sure. So let's check this is. Just check this. Maybe no. So I'm gonna make a scatter plot right there. And then I'm going to have those x and y. Okay, so the x will be on the age, and y will be the age weight. Okay, so we're gonna have the x here, and then the y here. And I might make it very small. And this one also. Okay. X will be the age. All right, so anyhow, we have 3, 6, 12, 18, 24. We have 3, 6, 12, 18, and 24. Okay. So I want to put them down, this guy as 3, 6, 12, 18, and 24. All right, and then we're going to have from 60 to 95. So we have 60, 95, 140, 170, and 185. Okay, I'm going to put them down. This one is 60. And this one is 95. I'm not going to do all of that. I just put the top part of it. I'm not having enough space, but if you have space, you can do all of the numbers. So and now I'm going to make a scatter plot for that, right? So 3 go with 60, I believe. So 3 go with 60 right there. So we have 1 point. So in this case, we have 5 data set, right? N equal to 5. So we should predict you have 5 points on the graph. So 1, 2, 3. I'm going to count a point. On the exam, I'm going to count a point. How many points that you have on the list, and to see whether or not you have the correct correlation. So other than that, so for the scale, I usually do not really bother that much. But I want to look at the value that you put down, and that's pretty much the thing that grade the exams. So 6 have to go with 95, and 12 have to go with 140, and then 18 have to go with 170. And finally, that we have 24 have to go with 185. What do you think? What do you think?
Positive.
Positive.
Yeah.
Okay. Because?
Time's up.
Time's up.
Correlation because this trends up. Okay. But for the partial question, it might give us the y equal to fit 5.9 plus 5.9 x plus 55.7. But the question would always give us the x. So how can we figure out the x?
Is there?
Right there, right? So x equal to? So we're going to use the x when x equal to 3. What happened?
Using the calculator.
Should we do it on a calculator or should we do it by hand?
Calculator.
Absolutely. You're going to do it on a calculator. So y will be equal to 5.9 times
here.
Y equal to 5.9 times the x equal to 3, and plus 55.7. Okay, so can somebody help me do the math real quick for that? So take 5.9 times 3 plus 55.7. And we got the answers, which is 73.4. So we should expect if the pony is 3 years old, 3 months old, it has to weigh equal to 73.4 pounds. I'm sorry, 73.4 kilograms in terms of universal measurement. Okay, so this is a fact. That's it. And then we're going to box the answers. Just want to make sure that we do not make any mistakes on it. Okay, so that's pretty much a thing for chapter 4. Any questions?
No.
No. Okay, so chapter 5, just go into like the concept, and then I will let you go real quick, maybe 5 minutes for that. Okay, so the probability is really, really important. because it's gonna be like a main focus on the final exam, on the third exam, and the final exam. So it's not gonna be easy topic for all of us. But since we're not gonna like spend too much in order to master it, the probably is gonna take like a lot of time, like a few years. For me, it took me around 3 to 4 years to master this single topic. The probability is one of a very, very important perspective in statistics. So one of the thing that we can read for the probability, I would say, when we predict the weather channel. So let's say we go to weather, go to NYC, that you can literally check that it's always concerning the percentage, right? The 5%, what that 5% means to it, like precipitation. So meaning that we have 5% chance that it will be raining today. And then when you go to the next a few days after that, let's say next Tuesday, there will be around 50%. Wednesday, that'll be 60%. Monday is 20%. So all of that number are concerning with probability. When you predict something, is always have to go with the odds. So the odds will be the probability that something will not happen or will happen. So so let's say I would 20% change that it will be raining. Well, I mean, I would be very likely to believe that there will be 80% chance that on Monday it will be shiny, it will be sunny, it will be a very good weather, but the odds, meaning that 20% chance that it will be raining, it's not going to be a good day, right? For instance, so so that 20% will be concerning with the probability. So what is meant by the probability? So the probability is super important because we don't know anything for certain. We always have to be uncertain. We always have to be suspicious of what we're doing. And statistics will always be the same, because what we have to do with a statistic is when we deal with a sample. But what we have to make a decision will be on the population. So that is on the big jungle. So there's always the chance that things go wrong, but the majority part of it is when we go into with the pattern. So the probability is super important when we use a certain model and you want to make some prediction on it. You want to see whether or not that model is valid or not valid. So generally, when we predict this, when we look at the channel for that, we can literally check. It's always concerning with the percentage, and that's really important when we want to predict something. So generally, probability is the likelihood, right? Is the likelihood. It's something that is the likelihood that an event or anything like that, any concern, any information that we collect can occur. Okay, so the probability usually between 0 and 1, 0% and 1%. So that's really important. So 0 to 1%. So what we going to denote the probability, we're going to use the P and E. So E just an event, it doesn't really matter what we're going to do with. Okay, so the probability that we use the keyword P, to use the P to represent that. So this is the P, yeah. And then, so P of E, so for instance, I'm gonna put them down like this. Okay, so I'm gonna call this as the P and E generally. So let me just highlight that real quick. So the P represent the probability and E represent the event, something that we take into account. So we also have something that is usually, there's no such a thing that is going to be 0%. It's very rare that you're going to see something with 0%. But if this is the case, 0% meaning that what it means by zero probability, the 0 percentage. The 0 probability meaning that it never happened, right? Something never happened. Never happened. And so for 100% is something happened for certain. So we're gonna put them down and we're gonna change with this marker and I'm gonna put it right there. Okay. And 100% meaning that something happened for certain, but there's no such a way that, we always know that it's always happened. So there's always be something that happened for certain. It's also very unrealistic for certain. How can you find something that like 100% sure? There's always like, if you can be 99%, but there's still be 1% chance that it go wrong. Who knows? But if you know something happened for certain, then so that would be 100% probability. Okay. So that's really important that we understand the difference between percentage and probability versus probability. So those are two different topics. Okay. So let's say I give you one example, what it means by percentage. I would tell you that there were around 85% of my students passed my class last semester. So what does that mean? Meaning that that percentage associated with the past data set. Okay, so the probability is what? Probability is something that we don't know. And you want to predict that. You want to calculate that. We want to formulate that. So that percentage that associated with probability is something that we don't know for certain. But for the percentage, this one will be something that we know for certain. Okay, so for instance, I have like 85% of the people pass my class, so this is the percentage. Okay, coming from the past data set. Okay, so the probability is something that we have some information, and we want to predict them. Okay, so we predict the future data sets. In other words. Okay, so those are two different things. Or in other words, it can be predicting the trend of the data sets. This is also something that really important, and the thing that we going to spend the time working on next class. Okay, so I feel like it's really tired. I know most of you passed out already, so I apologize for all of these things. So we finish chapter 3, we finish chapter 4, and then we going to be working on chapter 5 next Saturday. Okay, so make sure that when we come back next Saturday, it's going to be like also a long day to work on because of the fact that chapter 5 is going to be the most difficult chapter. I want you guys, the most complicated chapter is on chapter 7, but the most difficult part of chapter 5, it will be chapter 5 because it's complicated. Is when it comes to probably it's always really complicated, and you will be wondering how the heck people actually got this percentage, like how people predict that there will be 20% precipitation, like raining or not raining, right? So it is really not quite easy things that people do, right? So when you look at the channel on Google, you can literally check what it is, but how people formulate that will be a different story. But anyhow, I feel like it's too much for that. I'm going to take attendance, and then I will let you go assess Natos here.
Professor, I have a question.
Assignment today?
I'm sorry?
I have a question.
Yeah.
Which one's going to be the chapter for the next exam?
The next exam will be on chapter 2, 3, 4, and 5. So we try to finish chapter 5 next Saturday. And then after that, we're going to have the review. And then after that, we're going to have the exams.
Okay.
All right.
Professor, no assignment today?
There were some assignments, yeah.
Yeah, it's right there.
If they always be there, you can check them up real quick. So that will be on chapter, so assignment 4. Okay, so we need to make sure that if for those of you who, I'm going to make those homework 1 and 2 unavailable, so we can submit it. Okay, so making sure that we're going to continue working on homework 3 and 4. And so that's important you finish homework 4 next week.
Mm-hmm.
But try to do it as soon as possible. I feel like if you learn it now, it's always good to practice right away. It's going to take you another 20 minutes to do it. But when you wait until like next Friday, all of a sudden you have to open the notes and you don't know what the heck was going on.
Very lost.
Is you're very lost, and then you have to spend maybe 3 hours catching up all everything. it's not worth it. So I always recommend people just study right away after the class. I know you get really tiring, but please, you know, it's always suffer now, then you suffer more tomorrow. So Jessica's here. You didn't. I think I agree everything. So Marshall, yeah. So the thing that was the fire, I'm gonna email you for that. Jessica is here.
Professor, I have a question. I sent my homework 2 and homework 3, but I didn't see my grade.
I think I agree everyone. But let me just double check that for you. What's your name, Miss?
Kalpana Bawali.
Okay. Yeah. So I'm gonna check that for you. Jessica is here.
Professor, can you check mine too?
Yes. Just tell me your names.
And mine too.
Yeah. So.
Nazario.
Okay, so after that, we're gonna get on Zoom on the hour, so office hour on Zoom. So we click on a link after this class, and then we're gonna check them out real quick. Okay.
Break. Take your break.
Yeah, give me a break for that. David is here.
Davina is here.
Yes, absolutely. I like that. Dev is here.
Yes,
Blaze.
Davina's here.
Blaze. But okay, I got you, Marshalls. So Blaze, no,
No, I'm here. Blaze is here.
Oh, Blaze is here. I apologize for that. So typing is always better. I apologize for you, sir. And Calpona is here for sure. Monica is here. David is here. And Johanna is here.
Here.
Fantastic. Thank you, miss. And then we also have Asisto.
Yes.
Absolutely. Mai is here. Marsha is here. Montleen is here.
Yes.
Sophia.
I'm here.
Here.
Ranier.
Here.
Martinez. Matt. Matt, sir. Matt is here. Matthew. Matthew going once. Marisol.
Here.
Very good. Dukas. Dukas going here. Very good. Fantastic. Tammy. Tammy. Tammy going once. Patrice is here. Kawuchi is here. Absolutely. Kawuchi is absolutely here. Junior. Yeah, Junior is here.
Yeah.
Fantastic, sir. Nick. Nick is here. Yeah. Melissa's here.
Here.
Azir is here.
Here.
Very good. Anna.
That's mine.
That's yours. Thank you very much. And Marlene.
Here.
Marlene is here. Israel. Israel.
Here.
Very good, sir. Stephanie.
Yes.
Stephanie, like you have a few classwork. Like I'm not sure. You need to see me in the office hour, and we're gonna have a little conversation about your classwork. Okay? I'm sorry.
Okay.
Homework problem. Olivia.
I'm here.
Okay. Very good. So that's pretty good for today. If you have any concern, remember that we only go to the office hour one by one. If I ask you to leave, I have no intention for that. I just want to open the classwork or homework from that person, and then can come back later on. So, okay, so it have to be one by one because I can't share the file for all of us like at the same time. So if you're in the office hour, you might have to leave for like 2 minutes or 3 minutes, and then you come back later on. So okay, so I can open the classwork for that person individually. So for those of you who have a name, so make sure that you're gonna click on the office hour in Zoom. I will be there around I would say 15 minutes. So I will be there around 11:20.
15.
So you want to be there? I need to drink some water and take a break with my dog a little bit. Come on.
Okay.
All right. So I see you in 11:20 for those of you who want to see me in the office hour, and for those of you who do not, if you got all the grades, congratulations. And then we're gonna have something to do next week. Okay. So you guys have a great day, and have a great weekend, and take care.
Thank
Okay,
you, Professor.
bye-bye.
You too.
Thank you. Take your time.
Okay, bye bye.